So this last notes is on triangle similarity, and all of these problems are similar. And similar not in fact they're similar triangles, but they're the same type. One of the rules that we learned is angle-angle similarity. Now, if you notice on problem 1 and problem 2 and problem 3, you have two triangles. You have the big triangle and the little triangle. You got to be seeing two triangles here, the little triangle and the big triangle. And then you have these parallel lines. Now, if these lines weren't parallel, I wouldn't be able to do this problem. These lines being parallel gives me congruent angles. Now, I could have congruent angles marked, but if you see on these problems, they all have the parallel lines. And so they're all the same type of problem. Okay, so you have the little triangle, which has this top angle, and you have the big triangle that has this top angle, so they both share this top angle. That would only count as one angle. Then you have these two angles. Now, these two angles are not alternate angles. They make the Z shape. Does anybody remember what these two angles here are called? Mason?
Is it corresponding?
Those are corresponding. If they make that F shape, those are corresponding. So, good job, Mason. So these are corresponding angles, they're congruent. These are corresponding angle, these are congruent. This angle, it might not look like there's another one, but this one's congruent to itself. So in the little triangle, this angle's in there, and it's in the big triangle, so it's congruent to itself. Does anybody remember what it's called when it's congruent to itself? You can yell out. What's nice congruent to itself, what's that called? Reflexive property. So that's reflexive property. Okay, so what we're going to do is we're going to separate these triangles out. So I want you to draw two triangles, a little triangle and the big triangle. And sometimes the problem is a little bit on the easier side. You might not need to do this. But I would really recommend that you do this because it makes it really easier to see what's happening and will prevent you from making some very common mistakes. So this side of the big triangle is not 25. Just yell out, how long is this side, this big triangle side? 40. Because it's both of these, 25 plus 15, so that's 40.
I did 25 minus 50.
Okay, that's okay. So we're talking the big triangle, right? That 15 is only from here to here, and the 25 is only from there to there. So the whole thing is 40. And this whole side, I don't know x, but I do need to write something down. It's not 18x.
18 plus
Okay? 18x means 18 times x. And so a lot of times people say that, they'll say 18x, but that means multiplication. So yeah, you're right. 18 plus x or x plus 18. I always like to write the variable first, but it really doesn't make a difference. 18 plus x plus 18 are the same thing. So that's the big side of this triangle. Okay, now you have the choice. You could do proportions or scale factor. And we know which one the big triangle is. There's no doubt that this is the big triangle. It has to be the bigger triangle. This one can't be where this triangle is smaller than the other one. So I could do proportions or I could do scale factor. Let's do the y first. Okay, the y is a little bit easier. So the y and the 64 go together. And I don't want to use the 18 and the x plus 18 because I don't know what x is. So I'm going to use these two. Okay, I need to use, in a lot of cases, two numbers that I know. There are some times when you might need to use a situation where you have both x's or something like that. But in this one, if you have two numbers that match together, you're going to use those. And the 15 and the 40 do go together. I know we didn't do this on this diagram, and I don't really think it's necessary since these are in the same orientation. Oops, I hit the wrong button there. These are in the same orientation, so I don't. Whenever you write in the top of the screen, it's dangerous. So these are in the same orientation, so I don't think it's necessary to label the angles, but if it helps you to label the angles, it's not a bad idea. Okay, so anyways, the 15 goes with the 40 as the y goes with the 64. 15 is in the little triangle, 40 is in the big triangle. Y is in the little triangle, 64 is in the big triangle. So that's how I did mine. I could have done big triangle over little triangle. So I cross multiply, I get 40 times y. And I have 15 times 64. Did anybody do that? 960? Okay. So I get 960. And then I have to divide by 40 on both sides. Now these don't always come out to be whole numbers. So if you do get a decimal, I would not assume that that is wrong. But I know my answer has to be less than 64 because it's a smaller triangle. So I get this. Now, if you do find the scale factor, you got to make sure you don't go 15 over 25. 15 over 25, though, that's not even part of a triangle. This 25 is not side of the triangle. You got to go 15 over 40 or 40 over 15. Now, 40 over 15 is equal to 8/3. So if I'm multiplying this way, it'd be 8/3. If I'm multiplying this way, it'd be 3/8. So I'm just going to do 64 times 3/8. 3/8 of this number is 24. So I could do scale factor. Scale factor on this one I could do also, but I'm going to do the proportion way. Most people like the proportion way better. There's 3 ways to actually do this one. So I want to say all 3 ways. I could do scale factor. I could multiply this by 8/3, find the number, and then solve for x. I could do this proportion. 15 goes with 40 as 18 goes with x plus 18. I could also make this a different letter. I can make it z, and I go 15 over 40 equals 18 over z. Now z wouldn't be the answer, but then I would take z and set it equal to this and solve for x. That's the 3rd way to do it. I would love to show you all 3 ways, but that would put some people to sleep, but we don't want anybody to fall asleep, so we're just going to do it one way. So I'm going to multiply 15 times x plus 18, and I'm going to multiply 40 times 18. And I really don't suggest doing distributive property in your head. I suggest writing this out. But if you do want to distribute and you feel good about jumping to this step, I'm not going to stop you. So I have to cross multiply this and solve. I'm going to subtract 270 from both sides. I get 15x equals 450. And I'm going to divide 15 on both sides. Let me just roll through. I subtracted 270 here. This one comes out to be a whole number also. And the nice thing about doing it this way is that the x is 30. You don't have to do any additional steps here. And then you could test out that 30. This side would be 48. So make sure that you're not saying, 18 times 8/3 is 48. That's, is not 30. Well, it's not 30. This side's 48. And so then you could divide to check these answers. You could check to see if side works. We're doing angle, but you could check all the sides to see if they're proportional when you're done. Everybody happy with that one? Okay, we're going to do number 2 the same way. So if you want to jump ahead of me on this, you can. I'm going to separate the triangles. I'm going to make proportions. I'm going to find these. This is essentially the same except for it's turned. So try to draw the 2 triangles. It's always best to be a step ahead if possible. Okay, so again, I highly suggest you do this And if you feel like you could skip this, I mean, you could try, but I don't think it's a great idea. Try to draw the smaller one so that it actually looks smaller. And there's no reason to turn them or rotate them. If you think it's easier to rotate it, I mean, you could do that, but I don't see a reason for doing that. Again, if the lines are not parallel, I can't do this. I don't have any angles marked here, but again, these are always corresponding angles that are congruent if the lines are parallel. And again, the orientation is the same, so I just went for it here. The N is easier. I'm gonna do this problem like this. I'm gonna go 20 over 15. So I went large triangle on top, small triangle on the bottom, and then 36 goes with N. Just to show you that the N is not, or the variable is not always on the top. I could have these both flipped. As long as the 20 is across from the N, I'm doing it right. Some people might do it like this. They might say 36 over 20 and then N over 15. That will work too. I don't do it that way. I always go triangle to triangle. But as long as the 20 is across from the N and the 15 is across from the 36, it is the same. Is it 27? Okay, so N's 27. And then I have to do the M. And like I said, if you are like, scale factor seems much easier, then that's what you should do. Scale factor on this one is 3/4. So I could have multiplied 36 by 3/4 and got N. Okay? That's a good way to do it. It's also a good way to check it. The scale factor here would be 4/3. I can multiply 18 times 4/3, but I still would need to solve for M. So I'm just going to do this the proportion way. So I'm going to say 20 goes with 15 again. That's big triangle on top. So the M plus 18 goes over 18. I know these two problems, they seem identical. They're not always going to be exactly like these two. And you'll see that on the next one. But a lot of times you do end up with distributive property. So these two are like the most common ones that you'll be asked. Let me just show you how some people make mistakes. And some people try to do this in their head, and they go like this. They say, oh, this is 15, this is 5, so divide by 3. And they're like, oh, so then this one must be 108, because 108 divided by 3 is 36. And you can see how that would make no sense. That one can be 108. So you got to make sure you know that 5 is not a side of the triangle. 20 is a side of a triangle. 15 is a side of a triangle. So I'm going triangle to triangle. Yes?
Could you find M by doing 18 over 15 times 5?
18 over 15.
Yeah.
So, okay. I think I know what you're doing here. You're kind of like looking at these ones, right?
Yeah.
And so these ones are like this 5 and this M are not part of triangles. But you see how this is a divide by 3? And if you divide by 3, you do get 6, and it is 6.
Yeah.
So if you were talking about these 4, you can do a different proportion. You could say 15 goes with 5 as 18 goes with M, which is kind of what you're doing, okay? And it would be the same thing over here. I could say 15 goes with 25 as 18 goes with X, and it would work.
Yeah.
The thing that I'm worried about is people going 15 goes with 25 as Y goes with 64. That's not going to work.
Okay.
if you're using these inside ones, then you have to use the big side of the triangle, the 40. So I can't go 15 goes with 5 as n goes with 36.
Okay.
So it does work for the sides. There's actually a name for that called the side splitter theorem. And so for these ones, the sides that are split, you can use proportions for that.
Oh, okay.
Okay, but you couldn't do that to find n. So that's why I don't show people that way, because I'm worried that people are going to go 15 over 5 goes with n over 36. And so to answer your question, you could definitely do it that way.
Okay. But I was wondering, like, if on the test there'd be like a different type of triangle that the m would only be able to solve like the other way that you taught us. Or...
Well, if this was the number that I was given and this was the missing one,
Yeah.
okay, then I would go the way I taught you. It'd be 15 over 20, and then m over m plus 6, and there'd be 2 letters, but we could do that, and we actually do that in the next one.
Okay.
But then the way that you were asking, I go 15 over 5, and m over 6 would work. Okay.
All right.
Does that answer your question?
Yeah.
I'm trying not to tell people too many ways, because that can get confusing. But that way that you said does work, as long as you don't do that with the middle ones. Okay, so here's going to be one where I'm going to have two x's in the problem. Okay, so it is a little different than the last one, but I start the problem the same way. I'm going to draw 2 triangles, the big triangle, the little triangle. I don't have all 3 sides, and that's okay. It only says find x. So that little triangle, I have a 15x plus 2. The big triangle, this is 2x. And the biggest mistake people make is writing 9 right here. Okay, if you write 9 right here, the problem's not going to work. If you don't separate the triangles, you might end up using the 9. You got to know that this is 24. Okay, so you got to use 24 on this problem. There's no other way to do it. Everybody happy with my recreation of the 2 triangles? Okay. Now, whether you do big triangle over small triangle or small triangle over big triangle doesn't make a difference. Whether you do the triangle on the left over the triangle on the right, or triangle on the right over triangle on the left doesn't make a difference. I'm going to go 24 over 15. Now, see if you know how I would match it. How you write the first one doesn't make a difference. It's the matching that matters. So these 2 go together, the 24 and the 15. And I just got to match it. So I did big triangle on top, so it's got to be 2x. Little triangle on the bottom, x plus 2. And so this might happen, for any missing side where you end up with no number on one of these. But we know how to cross multiply these. So it's not going to be a big issue. It's just going to be a little bit harder to solve. If you ever have an x and a y, that you can't solve. I have 2 x's, no big deal. So I do 24 over x plus 2, and then 15 times 2x. This one I have to distribute. This one I just multiply these together. If you ever get a negative for your final answer, something's wrong, but you might get a negative during the steps. It doesn't really happen on this one, unless you move the 30 over, which I wouldn't do. But if maybe I said this the wrong way. X could be negative. Steps could be negative. The sides can't be negative. So the final answer can't be a negative side. And I think I don't get a negative here. I get 8. And then that would mean that this side's 16 and this side is 10. And then again, you could check with scale factor. You just got to know for the scale factor, don't do 9 over 15 or 15 over 9. You would do 24 over 15 or 15 over 24, and then you could test. This side is 10 and this side 16. The scale factor from big to small would be, I don't know why I'm typing this in my calculator. This is 5/8. It's 5/8, right? Dividing these will give you 5/8, and 15 over 24 is 5/8. So going from the big one to the small one is multiplying times 5/8. The other way would be times 8/5. You could check that way. It only asks us for x. I would still really consider checking. Okay, we're gonna do one more. One more problem. It's the same thing. You'll see this one's maybe a little bit different. I have AB equals 18, so I got to write these down. BC equals 12. I don't know if you noticed this, but on the first two problems, this was an unknown thing, and even on the middle one, there's an unknown thing, so it is a little bit different. DE equals 24, and BD we don't know, and AD I don't know. Okay, so I put those numbers down. Oh, CE is 6, so I do need that. So, maybe the reason I didn't write that is because I don't think that's going to be helpful. It only asks us for AD and BD. And so I need this one. So I'm going to put X on this. Okay. Now, sometimes people do what I was talking about here. They say, you know what, this is simple. I'm going to go 18 over X and 12 over 24. That's not going to work. Okay, that will land you with this being 36, which is bigger than what the answer is. Some people do this. They say, oh, it's times 2. The scale factor of these triangles is times 2. It is times 2. 12 times 2 is 24. But I don't do 18 times 2. You might say, well, you just said it was times 2. From triangle to triangle, this X is not part of the triangle. This is not part of any triangle. So it is not times 2 here. X does not end up being 36. Okay, so again, I highly suggest that you draw these triangles separately. One of them is 18 and 12. The other one, I have 24 here. And I have this side being X plus 18. And this side, that 6 is not either one of these triangles. I don't have to find AC. It doesn't say to find AC. So I'm not even going to bother doing anything with this 6. Okay, I'm just going to ignore that 6. That 6 is not helpful. Again, I could do scale factor. If you're like, well, this is easier with scale factor, then do it, okay? Because I think on this problem, for sure it is easier with scale factor. But let's just do it the proportion way, and then we'll talk about the scale factor way. Okay, I'm going to do 12 over 24 first. 12 goes with 24 as 18 goes with X plus 18. Then I have to cross multiply. The way I'm showing you is the way that always works. I'm distributing. I'm moving the 216 over. It just coincidentally comes out to be 216 again. And then I get 18. You might say, well, 18, that seems weird. It's actually not weird. These figures are not drawn to scale, so it might look like this has to be smaller, but we don't actually know that that has to be smaller. Like AB looks bigger than BD, but again, things don't need to be drawn to scale, and I'm getting 18. And then I can ask myself if that makes sense. Well, that would make this side of the triangle 36. And it does make sense, right? We said the scale factor is times 2, right? 12 times 2 is 24, and 18 times 2 is 36. 18 is the number that makes that side 36. So that is the answer. Oh, well, that's the answer for for BD. Sorry, that's BD is 18. We said what AD is. That one's 36. And I could find AC, but I don't need to find that one. It doesn't ask me to do that. And you might say, well, you know, the scale factor seems so much easier. Just do times 2. Well, look at the one above it, right? If I knew the scale factor between 9 and 15, can I just multiply one of these to get the other? There is a way to do it, but it's harder. So in 3, the proportion way is easier. In 4, the scale factor way is actually easier. But the proportion way always works. So that's why I'm doing these all with proportions. If nothing else, the main thing is to separate the triangles and redraw them. If you don't do that, that's going to lead to mistakes. If you do that, you know, then you can use your own method that makes the most sense to you to get the problem done. Okay, that's